For this example problem, we want to approximate the slope of the tangent line to the graph of y equals x minus 1 squared at x equals 0, and then use it to find the equation of the tangent line to this graph at that point. So for slopes of tangent lines, we know we have to do the limit of the slopes of the secant lines, which, based on this function, looks something like the limit as x goes to 0 of y at the point x minus y at the point 0 over x minus 0. You can also write this as y of 0 minus y of x over 0 minus x. That'll give you the same answer with just two minus signs to cancel. So from this, I know that y of x is x minus 1 quantity squared. Y of 0 is 1. If I plug in 0, I get negative 1 squared, which is 1, divided by x. And I can approximate this two ways. I can approximate numerically. If I do that, I'll get the following. So if I plug in x equals 1, I'm going to get minus 1 just by plugging into that expression there. If I plug in, say, 0.1, I'm going to get minus 1.9. If I plug in 0.01, I'm going to get minus 1.99. And so it looks like this is heading towards minus 2. Algebraically, I can do the same thing. If I expand out that squared, I will get that x minus 1 squared minus 1 over x is the same as x squared minus 2x plus 1 minus 1 over x, which is x squared minus 2x over x, because these 1's will cancel. And then if x is not 0, this is the same thing as x minus 2, because I can cancel the x on the top and the bottom. So because the limit doesn't care about the actual value at 0, the limit as x goes to 0 of x minus 1 squared minus 1 over x is the same thing as the limit as x goes to 0 of x minus 2, which is minus 2. Same answer we got before. Now what that means then for the equation of the line is I can just write that in point slope form. So that's going to be y minus a point y0 is m times x minus x0. The point I have here is x equals 0 and y equals 1, which is the same value that I got over here. And my slope should be minus 2. The equation that I then get is y minus 1 equals minus 2x minus 0, or y minus 1 equals minus 2x. Or if you want to add 1 to both sides to get it in slope-intercept form, you can do that as well. And that's how you work out this problem here.